Hi, good morning, my dear students. I'm Miss Stephanie Cole. Welcome to my channel, Spark Brilliance, Inspire Life. A substance is said to be pure if it contains only one chemical compound. In real life, the sample that you are given may not be 100% pure, could contain water vapor, impurity like sodium chloride or other salts, dust or other impurity. In this video, the chemical we are analyzing is sodium sulphite, a chemical compound that can be used in food processing, water treatment, and as a reducing agent in chemistry. However, we cannot determine the amount of pure sodium sulphite directly. Instead, we use redox titration method to find out how much of pure sodium sulphite in the sample is truly pure. Instead, we use a redox titration method. This allows us to find out how much of pure sodium sulphite in the sample is truly pure. Then we can use the following formula to calculate the percentage purity of sodium sulphite. I will walk through each step, the procedure, the reactions involved, the titrations, and finally, the calculations to determine the percentage purity of sodium sulphite in the sample. At first, we will take 10 cubic centimeter of 0.2 mol dm³ sodium sulphite, react with 50 cubic centimeter of 0.05 mol dm³ iodine solutions, add in 1 gram of sodium hydrogen carbonate. The sulphite ion can be oxidized to sulfate ion by iodine in the presence of hydrogen carbonate ions. Iodine oxidizes sulphite ion in a 1:1 ratio, and any iodine that doesn't react remains in the flux. Then, titrate the unreacted iodine using a standard solution of sodium thiosulphate. This allows you to calculate the mole of iodine that did not react with sodium sulphite. Now, let's look at the procedure of the experiment. Part A, the reactions of sodium sulphite with iodine. Part B, the reactions of sodium thiosulphate with excess iodine. Record the volume of sodium thiosulphate used in the table below. Then, using two readings, calculate the average volume of sodium thiosulphate used. Let's look at questions A, the chemical equations involved in these reactions.